Here's a second video showing solutions to the Unit 1 review problems 6 through 15. Okay, for number 6, this is a literal equation. We're asked to solve for m. So I want to get all my m terms to one side. I'm going to subtract mt. So we'll have my, I'll just put the minus mt next to it, and then a minus 8 equals 9. And then I'll add 8 to both sides. So we'll get my minus mt will equal 17. Now remember, in order to go from seeing these two terms down to just a single m, we want to factor out the m. And then we're left with y minus t inside the parentheses, divide by that. So m is going to equal 17 over the quantity y minus t. For 7, we're looking at compound inequalities. Now for A, we're looking at an in-between statement. So my first step is to multiply everything by 3, and it's a positive 3, so I don't have to worry about the signs. I want to multiply this by 3, I want to multiply this by 3, and I want to multiply this by 3. So we are now going to get negative 6. We'll be left with a 4 minus x in the middle, and then that'll be less than 18. Now I want to subtract 4 from everywhere, so I'm going to get a negative 10. So negative x will be greater than or equal to negative 10, and then less than 14. Now I need to divide everything up here by a negative 1, and because when I go to do that, I need to switch the signs now. So now we'll get an x in the middle. This will give us a positive 10 and a negative 14. So now I just want to rewrite this. Right now it's showing us greatest to least, but the best way is to look at it this way, just in case we were asked to graph this, which I'm still going to do, and write this in interval notation. So we have a negative 14 and a 10. Closed endpoint on the 10, open on the negative 14, shade everything in between. So interval notation would be parenthesis negative 14 to 10 with a bracket. Okay, now for B, I'm just solving each one individually here. So I want to start by multiplying both sides here by a negative 3/4. So that's actually going to flip my sign. So I want to multiply this side by a negative 3/4. Technically I should be flipping the sign here, but just to show us now, our sign will flip. This will leave us with a y. So we could multiply 24 by 3, then divide by 4, or it's going to be a lot easier to say, hey, 4 goes into itself once and into the 6 times. It's going to be a positive, so then we'll get 18. Over here, I'm going to subtract a y. So we'll get 7 is less than or equal to y minus 3, add 3, and I want to flip this around here so it's easier to read. Y is greater than or equal to 10. So because this is an OR, let's put this on the number line. Here's my 10, here's my 18. I just need numbers now to satisfy one or the other or both. So I can't shade any numbers here because they are definitely not greater than 18. They're definitely not greater than or equal to 10. I will shade all numbers in between because all of these numbers are greater than or equal to 10, or they could be greater than 18. So I'm going to go over here, but I could still include the 18. I shade right over it because even though 18 is not greater than itself, it's still greater than 10. I'm going to include the 10, and then I just keep shading this way. So I really just get everything from 10 to infinity, and including the 10 that's there. Now, if this were an AND, I would only shade the numbers to the right of 18 because I'd have to have a number that's greater than both. And that only happens when you're greater than the larger number. All right, for C, now this one says AND. I want to start by distributing this. So we'll get a 3x minus 15 plus 1 is less than or equal to, distribute over here, 4x plus 8. Let's go ahead and just combine these numbers. So we get 3x minus 14 is less than or equal to 4x plus 8. This time, I'm going to subtract 4x. So we're going to get a negative x minus 14 is less than or equal to 8. I'm going to add 14. So we get negative x is less than or equal to 22. And I just realized I forgot the plus 6 here. So this will actually change this to a 14. And I'll make this a 28. Now I want to divide both sides by a negative 1, so I'm going to get x is greater than or equal to a negative 28. Now over here, to get rid of these decimals, I could just multiply everything by 10, so that will give me 3x minus 16 is greater than 2. And because it was a positive 10, I didn't have to flip anything. So now let's go ahead and add 16. So we have 3x is greater than 18. X will be greater than 6. So on my number line, I've got negative 28 and I have 6. I need the and right here. So I need all numbers greater than or equal to negative 28 and greater than 6. I can't shade anything to the left of negative 28. I can't shade anything in between because even though they're greater than or equal to negative 28, they also have to be greater than 6. So the only place that will satisfy both inequalities is to the right of the 6, but I don't include the 6. I just need numbers that would be greater than 6. So here I'm looking at 6 to infinity with parentheses around both because of the word and. All right, problem 8 gives us more absolute value inequalities and one equation I threw in there. Now remember, the goal is to isolate the absolute value part. So what I'm going to start with A is adding 1 to each side. So we'll get 3 is less than the absolute value of 4w minus 3. We're so used to seeing this written the other way around, and it's going to be so much better if we do. So we get the absolute value of 4w minus 3. Reading it from right to left is actually greater than 3. So this is a great or. I have to use or. And I have to go beyond. So we're going to say 4w minus 3 is going to be greater than 3, or 4w minus 3 is going to be less than negative 3. So here I want to add 3. 4w will be greater than 6. W will be greater than 6/4 or 3/2. Over here we'll get 4w is less than 0. And divide by 4, 0 divided by anything is 0. So we'll go ahead and graph this. So this one, we will be open endpoint shading to the right of the 3/2, open endpoint shading to the left of the 0. So we get negative infinity to 0, and we'll join that with 3/2 to infinity. All right, for B, we have to first get rid of this negative sign. So I have to divide both sides by a -1, and in doing so, I need to flip this. So we will get absolute value of 8 plus B is now less than or equal to a positive 6. So we can proceed because this is a positive value here. And this is an in-between statement. It's a less than. So I want to say negative 6, or 8 plus V, is going to be in between negative 6 and 6 inclusive. So I just need to subtract 8 from everywhere. So we'll get V is greater than or equal to negative 14 and less than or equal to negative 2. Put that on a number line. Closed endpoints on both of these. Shade in between. So we'll have brackets, negative 14 to negative 2. All right, for C, you see an equation. I first need to get the absolute value term by itself, so I'm going to subtract 9. That will give me a negative 8. Guess what? This is a special case because this side is going to be positive or 0. This side is negative. That is never true, so we would say no solution. Again, you can use this symbol or the empty set or just write out no solution. Now for D, it's sort of similar. It's still going to be a special case. 3x minus 8 will be greater than negative 8. So again, this is positive or 0. We're going to compare it as being greater than a negative. This is always true, so this will be all real numbers. No matter what you substitute into here, it's going to give us positive. Then we're going to add 9 to it. So that will always turn out to be greater than 1, or in this next case, a positive will always result here on the left side, which will always be greater than negative 8. All right, looking at E, we want to start by subtracting 4, so we get the absolute value of x minus 13 is greater than 13. So again, this is a greater, so we're going to have x minus 13 is going to be greater than 13, or x minus 13 will be less than negative 13. So over here we'll get x is greater than 26, or x is less than 0. Open endpoints on both. We'll shade to the right of the 26 because we're greater than, shade to the left of the 0. So we have two interval notations that we're going to join together here. So we'll start with negative infinity to 0, join that with 26 to infinity. Okay, number 9 is using the distance formula. So just to write this out again, distance is equal to the square root of x2 minus x1, that quantity squared, plus the quantity y2 minus y1 squared. So when we go to use it for 9a, we'll have, remember distance is always positive, so you don't have to put a plus or minus in front of that square root there. It's already the positive square root. So I'm going to start with negative 2 minus 8 squared. That's actually the y's. It doesn't matter the order we go in. Then I'm going to have 4, careful here, minus a negative 1 squared. So this will now give me a negative 10 squared. Keep that in parentheses. And then this becomes 4 plus 1, so 5 squared. So now we're going to get 100 plus 25. We get the square root of 125. Now this simplifies into 25 times 5, which now becomes 5 radical 5. Now for b, we're going to have the distance is equal to, this time we'll start with the x's, negative 1 minus 3 squared plus negative 1 minus 0 squared. So I'm going to get a negative 4 squared plus a negative 1 squared. So this will give me a square root of 16 plus 1. We get the square root of 17, and we can't simplify that. Now for 10, we're going to work with the midpoints. So the midpoint formula, remember it's always an ordered pair. It's always the sum of our two x values cut in half, taking the average of the x values, and then the sum of the two y values divided by 2. So for a, our midpoint is going to become 8 plus 3 over 2, and then negative 6 plus 10 over 2. So this will give us 11 halves. This will give us 4 halves. We can simplify the 4 halves. So we get 11 halves, comma 2. Now for b, we're going to start with negative 2 plus 0 over 2. Then we can write it this way, negative 2 plus a negative 4 over 2. So this becomes negative 2 over 2, negative 6 over 2. So we get negative 1, negative 3. All right, for 11, we're asked to find the x and y intercepts. Remember, to find the x-intercept, just let y be 0. To find the y-intercept, substitute 0 in for x. So I'm going to label these. Let's first find the x-intercept for a. So I'm going to have negative 3. We're substituting in 0 for y. So negative 3 times 0 plus 4x equals 6. So this just goes away, turns into 0. So we get 4x equals 6. X equals 6/4 or 3 halves. So the ordered pair of the x-intercept is 3 halves, comma 0. For the y-intercept, we'll say negative 3y, then we'll put in 0 for x. So we'll get negative 3y equals 6, y would equal negative 2. So the ordered pair of the y-intercept is 0, negative 2, because 0 goes in for x. Okay, for b, the x-intercept, we'll have x equals, again, 0 is going in for y, so we'll have 0 plus 7 in the absolute value. So this will just give us absolute value of 7 minus 3, which is 7 minus 3. So that's going to be 4. So the ordered pair of the x-intercept is 4, 0. Y-intercept, we'll have x, sorry, that will be 0. X is 0. Then we'll have absolute value of y plus 7 minus 3. We have to add 3, bring that over to the other side. So we'll get 3 equals absolute value of y plus 7. So it's pretty good that we've been practicing absolute value problems. So now this means y plus 7 could equal 3, or y plus 7 could equal negative 3. So y is going to equal negative 4. Subtracting 7 here, we'll get negative 10. So the ordered pairs of the y-intercepts are 0, negative 4, and 0, negative 10. All right, for number 12, we're going to graph. So I highly recommend you switch to graph paper if you have this. It says to graph by making a table. So I'm just going to pull some x values here. And it really doesn't matter what you start with. I just want to do a few just to the left of 0 and a few to the right. And we'll see what we can do here. So let's try -3, -2, -1, 0, 1, 2, and 3. All right, so y is going to become -3 squared minus 2 times -3. So that's going to give me 9 plus 6, which is 15. So that's the ordered pair, -3, 15. I'm not going to be able to fit that on my screen here. Next, if we go with -2, it's -2 squared minus 2 times -2. So that will give us 4 plus 4, which is 8. So then we have the ordered pair, -2, 8. For -1, we'll have -1 squared minus 2 times -1. That gives us 1 plus 2, which is 3. So then we have the ordered pair, -1, 3. 0 is easy. That's just 0 minus 0. Now if we have a 1, we'll have 1 squared minus 2 times 1. So that becomes 1 minus 2, which is -1. And then we'll have 2 squared minus 2 times 2. We'll get 4 minus 4, so that's 0. So we'll have 2, 0. And then lastly, we'll have 3 squared minus 2 times 3, so it becomes 9 minus 6, which is 3. So then we have 3, 3. All right, so I'm counting all by ones here. So we're going to go, again, I'm not going to include the -3, 15, but if we have -2, 8, that would be right up here. -1, 3. 1, -1. 2, 0. 3, 3. Now you may not know what this looks like just yet, and we'll eventually get into graphing these, but this is quadratic and it graphs a parabola, so it's going to come something like this. So we call this lowest point here the vertex. So the vertex is actually at 1, -1, but like I said, all I wanted you guys to be able to do was just to graph by plotting some points, and that's what we would do here. So creating the table is more important. All right, for 13, our next couple problems deal with, actually the last 3 problems we're going to deal with in here, focus on circles. So for 13, A and B, they just want us to identify the center and the radius. So here, the center, so we take the opposite of this number, it's always x minus our h, so that means our h is 4. And then this was actually y minus a -3, so our center is 4, -3. And the radius is always the square root of this number right here, so the radius is 2. Over here, our center, now there's no value here, so that means our h is 0, and we would have 3/2 for our k, and then r is just the square root of 17. Now 14 just asked us in reverse to write the center, or write the equation of the circle in standard form given the center and radius. So this will become x minus the -3 becomes x plus 3 squared. Plus y minus the -1 becomes y plus 1, that quantity squared. And then when I square the square root of 11, I'll just have 11. For b, since our center is at 0, 0, we just get x squared plus y squared, and then 5 squared will give us 25. Okay, now for c, we have to do a little bit of work here. So we have our circle, and our endpoints, let's say this is the 1, -3, and then here's the 7, 5. So this is our diameter. So what we need to do first is find the center, which is actually the midpoint. So first, find the midpoint, which is actually finding the center of the circle. So the center then would be 7 plus 1 over 2, and then 5 plus a -3 over 2. That gives us 8 over 2, which is 4. 5 plus a negative 3 is 2 over 2, which is 1. Now to find our radius, we're just going to find the distance between the center and one of the endpoints. I'm going to use 7, 5 here. So the radius, I'm going to use the distance formula. I'm going to use this point and this point here. So I'm going to do 4 minus 7, that quantity squared, and then 1 minus 5, that quantity squared. So we're going to get negative 3 squared plus a negative 4 squared. So this gives me 9 plus 16, which is the square root of 25, which is 5. So my radius is 5, and I have my center. So then our equation is x minus 4, that quantity squared, plus the quantity y minus 1 squared. That would equal 25. All right, and then problem 15, we're given the equation of a circle in general form, so we want to write it in standard form and then identify the center and radius. So this, we have to complete the square. So I want to get my x terms together. I'm going to leave a little bit of space. I want to get my y terms together, leave a little bit of space, and then I want to take the 17 to the other side. So now we're going to complete the square. I'm going to go back to the 10x. I need to take half of 10, which is 5, square it, and that's what I add here, and I add over here. Then I'm going to take half of 2, which is 1. 1 squared is 1, so that's what I still need to add to both sides. And then I want to factor this. This will factor into x plus 5, that quantity squared. Then I'll factor this. This will factor into y minus 1, that quantity squared. Now we could say 25 minus 17 is 8. 8 plus 1 is 9. So then our center is negative 5, 1, and our radius is the square root of 9, which is 3. Very similar for B. We only have the x squared term, so there's nothing to do there. I want to separate this, leave some room, take the 3 to the other side. So now I'll take half of 8, which is 4. 4 squared is 16. So I still just have the x squared standing alone right now. Then I'm going to factor this. So this will become the quantity y minus 4 squared. And then this will give me 13. So my center is at 0, because I don't have an h value here, 4, and the radius is the square root of 13.